These are notes for objective 1.9. Use a calculator to find and evaluate a linear model. This is for September 8th. If we're given a set of data like we have here, where we see a sample size of many students, each of these points is a single student, how many hours they studied for their final exam, and what % they got on a test, we might want to visualize that data. And the best way to visualize that data is to plot it on a graph. First, we need to decide which one of these is the x and which one the y. And we could do that using our sentences. Does another hour of studying give you a higher test percentage? Or does a higher test percentage make you study another hour? I think it works better with hours studying as our x and test percentage as our y. So go ahead and label your axes. And test percentage. And then plot each of these points. We can't be exact with the points, but we can be pretty close. 547, 652, 865, 65, 1078, and 1077, 1291, and 140. And if we look at those points, we can see that the general shape of that relationship is a line. It is generally a line. So we call this data linear. There's a linear relationship between the hours you spend studying and the percentage that you get on your test. Now, in the past, you may have drawn a line of best fit here using a ruler and approximating the line so that it goes not through every single point but close to most of the points. And that line would look, something like that. You've estimated it in the past, but now we can use a calculator to find the exact line of best fit. And the way we're going to do that generally is to take this data, put it into the calculator, and then tell the calculator to find this line of best fit. So, to do that, I'll put the steps up here, and on this side, you'll be able to see the calculator here. I know you can't see all the buttons that I'm pressing, but I will talk about them as I press them. And remember that the data is also on that page, and that's where I'm getting the data. So you turn your calculator on, and we need to go to a place where we can enter the data. So press Stat, and you'll see that Edit is already selected. Press Enter, and you'll see an L1 and an L2. That's where we're going to enter the data, but we need to clear it out first. So move your calculator up and clear, and press Enter. Go to the left, go up, press Clear, and press Enter. Now in L1, we're going to put our X's, and in L2 go our Y's, and put them in order. So 0, 1, 5, 6, 8, 10, there's another 10, a 12, and a 14. Remember, I'm getting the data from the table that was above in this same notes. 10, 22, 47, 52, 65, 78, 77, 91, 100. So that's my X's and my Y's, my hours studying and my test percentage. So I've entered my data. Now I need to run the regression. I need to tell the calculator to give me the line. So press Stat again. Instead of Edit, we want Calc. So go over to Calc. And since it's a line, since the data generally looks like a line, pick Linear Regression, or LinReg. So scroll down and press Enter. One more time, hit Enter, and you get your linear regression. Now that is not the equation of a line, but it is the calculator's way of telling us how to write the line. I'd like you generally to round to the nearest tenth. So we would get y equals, and then the ax plus b here is basically the same thing as mx plus b. The a here is 6.4, so 6.4x plus 13.3. 58.6. And that is the equation of your line. That is the line of best fit, or the linear model. Remember, model means equation, to describe the data. Well, if we wanted to do something with that data, we might make a prediction. So if a student studied for 7 hours, what percent would you expect them to get? Well, first let's figure what 7 hours is. Is that our x or y? We determined earlier that the hours studying was the x, so I know that that's my x value. So x equals 7. And I can now plug that into the equation. So 7 goes into this equation here. Y equals 6.4x plus 13.6. That's a plus. So y equals 6.4 times 7 plus 13.6. Y equals 44.8 plus 13.6, which is 58.4. So 58.4% is what a student who studied for 7 hours could expect to receive. That's because I took my given variable and plugged it back into the equation. Flipping over to the other side, we can do the same thing. So, enter your data into your calculator in Stat, Edit, clear out your lists, and re-enter your data. In this case, here are my x's and my y's. So 10, 11, 12, 12, 14, 14, 19, and 21. Then, of course, my y values, 80, 77, 72, 63, 65, 40, and 30. Notice that the two lists line up. That's exactly what you need to have happen. Go to Stat, press over to Calc, go down to Linear Regression. You can press 4 if you want. Press Enter, and you get your linear regression. This time, notice our slope is negative. Again, we have y equals negative 4.6x plus 127.4. That's my equation that I am given by the calculator. Reading the rest of the problem, it asked me to make a prediction. If you had a football weighing 15 ounces, how far would you expect to be able to throw it? Again, 15 ounces is the weight of my football. That's my x value. So x equals 15. If I plug that into the equation, I get negative 4.6 times 15 plus 127.4. And y equals, if you plug that into your calculator, 58.4. So 58.4 yards. Notice I took the units from my y values. I took those units right there.